So, sodium. Atomic number is 11. Relative atomic mass, 22.99 grams. Subatomic particles, there are 11 protons, 11 electrons, and 12 neutrons. The electron configuration is 1s squared, 2s squared, 2p to the 6th, and 3s to the first power, simplified as Ne 3s to the first. Common chemical reactions with sodium are when sodium reacts with air. When burnt in air, it results in a white sodium peroxide with small amounts of sodium oxide. When sodium is reacted with water, it rapidly forms a colorless solution of sodium hydroxide and hydrogen gas. The isotope configuration of sodium, there are 20 isotopes of sodium that have been recognized, but only one, Na23, has been recognized as stable. There are 2 radioactive isotopes, however, and Na23, the percentage abundance is 100%. The melting point of sodium is 97.27 degrees Celsius, and the boiling point is 883 degrees Celsius. It is a metallic element, and then in its native state, it is a silvery white metal. It is not radioactive, but as said before, some of the isotopes of sodium are. Common uses are food preservative, necessary for the health, used in medicine. The date of discovery was 1807 by Humphrey Davy. In this video, we will be focusing mainly on the effects of sodium in salt. So in this experiment, we're testing how salt in a body of salt water affects the buoyancy of an object as opposed to a body of fresh water. So we found that the ratio of salt to water in a body of salt water is 16.98 grams of salt per every 500 milliliters of water. So right here we're measuring out 16.98 grams of sea salt. So there we got 16.98 grams of sea salt. So here we have 2 beakers of water with 500 milliliters each, the amount of water we used in the conversion, in the ratio. So this will be the beaker of fresh water, and this will be the beaker we dissolve salt into. So here we have 2 golden eggs with the same that weigh the same and have the same mass. So we're going to drop both of these in, one in fresh water and one in salt water, and we're going to see which amount of water, which egg displaces which amount of water. So we know that the displacement of water shows buoyancy. So for the experiment to work, we need the egg in the salt water to displace less amount of water than the egg in the fresh water. So we put 1 egg in the fresh water, and it goes to around 590 milliliters, and the other egg in the salt water, and it goes to around 570 milliliters. So we know that now the salt water affects the buoyancy of an object because the egg in the salt water displaced a less amount of water. So now, after this experiment, we can conclude that salt water improves the buoyancy of an object. So until about 100 years ago, salt was one of the world's most sought-after commodities, more valuable than gold, diamonds, and silver. The reason being that salt preserves meat by increasing the dehydration process. When the dehydration process in meat is increased, it retards bacteria growth, which is key when transporting meats, especially before the time of refrigeration. Transporting meats before refrigeration was vital to human existence because of the protein that meat provides to the human body and because of trade. So in this experiment, we're testing how salt affects the preservation of meat. So here we have 4 pieces of meat. This piece of meat is our constant and has no sea salt on it. This piece of meat, we're going to put 20 grams of salt on. This piece of meat, our third piece, we're going to put 40 grams of salt on. And our final piece of meat, we're going to put 80 grams of salt on. And all of these will be stored at a time and temperature constant of 24 hours and 4 degrees Celsius. So here are the 4 pieces of meat. This is our control. After being in the fridge for 24 hours, there is no moisture loss. It's still fairly tender and not very hard. This is the piece of meat with 20 grams of salt. It's a little lighter, it's a little harder, and there's a significantly greater amount of moisture loss in the control. This is the piece of meat with 40 grams of salt, and it's significantly lighter than the other piece, and there's also a greater amount of moisture loss than the piece of meat with 20 grams of salt. This is the piece of meat with 80 grams of salt, and it's definitely the hardest and lightest piece of meat, and you can see there's still some salt, and at the bottom there's a large amount of moisture loss as compared to the other piece of meat. Now we're going to weigh each one to see which weighs the least. Although the control did not have any salt on it, it still lost 0.9 grams in weight. Now a piece of meat with 20 grams of salt. This piece of meat lost roughly 10.9 grams in weight. So, by far, a greater weight loss than the control. Here's a piece of meat with 40 grams of salt. It lost about 16.9 grams in weight. So this is by far the piece of meat that had the most weight loss. And so now the piece of meat with 80 grams of salt. And despite having more salt, it actually lost the least amount of weight than the piece of meat with 40 grams of salt. It lost around 15.4, 15.5, 15.6 grams in weight. This is the main reason why salt was such a valued commodity. It preserved humans' main source of protein and main source of food, and it gave it a longer shelf life. This ancient practice is still used today in every country worldwide. And from this experiment we can tell that the rate of dehydration is not directly proportional with the amount of salt with a time and temperature constant.